I'm going to talk about solving systems of equations. Here I have a system of equations shown. Notice there are two variables. And the whole idea of solving this system is that I need to try to get this down to one equation with one variable so I can find a solution. So notice that y equals 3x minus 10, meaning it's the same thing as 3x minus 10. Anywhere where I see a y, I can replace it with that 3x minus 10. I'm going to have 4x minus 2 times the y value. Notice I'll leave a blank here where the y is because I'm going to replace the y with its equivalent, which is 3x minus 10. And that's still going to equal the same answer of 14. Now I can simplify this a little bit, multiply this through. So that's going to be 4x. It's a negative 2 times 3x, which is a negative 6x. It's a negative 2 times a negative 10, which is a positive 20. And that equals 14. And now I can combine some like terms here, and I can solve my equation. I'm going to find out that negative 2x is equal to negative 6. If I divide both sides by negative 2, I find out that x is equal to 3. And now I can use substitution again. I know that if x is equal to 3, I can put it back up here in for x. 3 times 3 is 9, minus 10 tells me that y is equal to negative 1. And so those are my two solutions to my system of equations. This time I'm going to solve a system using the elimination process. I usually use this when I don't have a value of x or y, and a lot of times if you solve for x or y, you're going to end up with fractions and it just gets kind of complicated. So the idea of elimination is that you can add the two equations together or subtract the two equations to cancel a variable. Usually it doesn't matter which variable you pick, although sometimes it's easier to do one over the other. In this equation, I'm going to cancel the x's for no particular reason. Notice that I have a 3x and a 5x. 3 and 5 both go into 15. So if I could get a 15x and a negative 15x with my two equations, I could set up a cancellation that will allow me to solve this equation. So my tool is that I'm allowed to multiply the entire equation by whatever I need to get that missing value. 3 times 5 is 15. So I'm going to multiply the entire equation by 5. That's going to be 15x minus 10y is equal to 40. The second equation, I like to add and have opposites. So I'm going to multiply the entire second equation by negative 3. And I'm going to do a negative, so I have a negative 15x. So negative 3 times 5x is negative 15x. You can see that those two values there would cancel. Negative 3 times positive 3 is negative 9y. And that's going to be equal to negative 3 times 26, which is negative 78. Okay? You can add your two equations together. 15 and negative 15 add to 0. I'm not going to write down the 0 though. Negative 10y and negative 9y add up to negative 19y. 40 and negative 78 add up to negative 38. Now I can divide both sides by negative 19, and I end up finding out that y is equal to, interestingly enough, positive 2. Looked like it was going to be something more complicated. Now I can take y and I can substitute it back in any of these equations. That second equation looks pretty easy because all the values are positive. So I know that 5x plus 3y has to be 26. I know that y is 2, so that's going to give me 5x plus 6 is equal to 26. Of course, you can subtract out 6 on both sides. 5x is 20, and if you divide both sides by 5, you end up finding out that x is equal to 4. So x is 4 when y is 2. And keep in mind, you can substitute back into any of these original equations, and that solution should work. Now I want to show you how to solve a 3-variable system. The idea is very much the same. You want to get this down to, actually you want to get it down to equations with only one variable, but first you want to get it down to two equations with two variables. So I'm going to use elimination. For no particular reason, I'm going to cancel the z's first. And I'm going to focus on these two upper equations because I notice I have a 4z here. If I multiply the second equation by negative 2, that'll give me a negative 4z, which will cancel. I think that's going to be pretty easy. So my top equation in this case does not need to change. It's going to be 2x plus 3y plus 4z equals 4. My second equation I'm going to multiply by negative 2. So that's going to be I'm not going to write that down here because I'm going to need to use that equation again in a minute. That's going to be negative 6x plus 4y minus 4z equals positive 6. So second equation got multiplied by negative 2. And what that does, when I combine these two equations together, 2 and negative 6 adds up to negative 4. I get a 7y. Notice the z's, opposite signs, those cancel. And I end up with that equaling 10. Okay, so there's one equation written with just x's and y's. Now I need to do the same thing with two other equations, and it doesn't matter which other two you choose as long as you pick two different ones. I'm just going to pick the second and the third. So in this case I'm going to have 3x minus 2y plus 2z is equal to negative 3. I'm going to have 4x plus 2y plus 5z is equal to positive 3. I do notice there that the y's would cancel already if I add these two equations, and if I'd noticed that sooner I might have tried to cancel the y's in both equations, but in this case we're still trying to cancel the z variables because we want another equation that just has x's and y's like the first one I set up. So I noticed that 2 and 5 both go into 10, so I can multiply my top equation by 5. I'd like to get a negative 10 down here, so I'm going to multiply that equation by negative 2. And the two equations I'm going to come out with, it's going to be 15x minus 10y plus 10z is equal to negative 15. And then my second equation is going to be negative 8x minus 4y minus 10z equals negative 6. Notice when I add my two equations together, I get a 7x, a negative 14y, the z's cancel, and I get negative 21. Okay, so up here, I have an equation written with only x's and y's. Down here I have the same. Now I can solve that system. So I've got negative 4x plus 7y equals 10 from the top equation. I have 7x minus 14y equals negative 21 from the second equation. Notice if I can multiply that top equation by 2, I'm going to get a positive 14y, and that would cancel the y's. So that's negative 8x, multiplying that top equation by positive 2. That's going to be negative 8x plus 14y equals 20. Bottom equation, 7x minus 14y equals negative 21. I did not need to change that equation in this case. Again, we're adding two opposites. So that's going to be negative x, y's cancel, it's going to be negative 1. If negative x is negative 1, I can divide both sides by negative 1, x equals 1. And now I can just go back and substitute into old equations. Again, it doesn't matter what old equations you use. I'm going to go back up here to this negative 4x plus 7y equals 10. I don't want to go to a three-variable equation here. I know x is 1, so that's going to be negative 4 plus 7y equals 10. I can add 4 to both sides. That's going to be 7y equals 14. Y is going to equal 2. And now I can go back into one of my equations that has a z and put those back in. So I know that x is equal to 1. I know y is equal to 2. So that gives me the equation 2 times 1 is 2. Let's go back up here. So 2 times 1 is 2, plus 3 times 2 is 6, plus 4z is equal to 4. That's 8 plus 4z equals 4. 4z equals negative 4, so z is going to equal negative 1. So there are my three answers. Not a very quick process, but on the other hand, I don't think it's particularly complicated either. You just have to be very, very careful and check yourself as you go. And you can solve a three-variable system pretty easily.